Part 1 of the heat temperature notes is on phases of matter. Before we continue, what I'd like you to do is pause the video, take out your composition notebook, and make sure that your table of contents is up to date. Your assignment number, the title, page number, the date, and all that. And once you've got that completed, press play again and we'll continue. So, the phases of matter: solids, liquids, and gases. One of the things that we'll focus on actually quite a bit over the next month or so is the speed of the particles. In a solid, the particles vibrate very fast, but they stay where they are. They don't actually move from one place to another. They're very orderly, as you can see from the diagram on the screen. They're just nice, and it's called a crystal lattice, and it's very nicely organized. The particles are vibrating up and down and side to side in all different ways, but they're not moving from their location. When we talk about solids, we're assuming that the shape of the matter is fixed. Now, granted, you could take a solid and break it, and then it would be in a different shape. But, not including anything like that, the shape of matter is fixed. It's the shape that it is. The particles are very close together. All particles are touching the particles that are adjacent to them. And that plays a critical role in some of the things that we're going to be talking about later. So very tightly packed particles. And the volume is what the volume is. The shape of the matter is fixed. The amount of space that it takes up, which is the volume, is also fixed. You can pause at any time during this, obviously, to make sure that you are following along. Don't let me get ahead of you. So let's move on to the liquid. When we talk about speed of particles they're actually faster than the speed of the particles in the solid. They flow over one another. They're not in that crystal lattice form anymore. They move from one part of the liquid to another part of the liquid. So it's very random. It's disorderly. And that's okay. That's just what they're supposed to be. The shape of the matter is variable. Whatever the liquid is, whatever container you put it in, it's going to take the shape of that container. So a liquid in a jar takes the shape of the jar. The liquid in a bottle will take the shape of the bottle. The spacing is interesting because they're still very, very close to one another. They're still touching the particles that are adjacent to them. It's slightly larger than the space between solid particles in a solid, but not by much. There's still a lot of contact between the particles. Again, really important that you know that. It'll come up again. The volume of the matter, however, is fixed. No matter what container you put it in, you're still going to have, your 100 milliliters, whatever container it's in. All right, moving on to gases. The speed of the particles in the gases the speed of particles in a gas are the fastest. Interesting in that they move in straight lines until they collide with either each other or the walls of the container, and then they're sent off in a different direction, like a pool ball, for example. The particles are very random. Sometimes you'll have two next to each other, sometimes they'll be really far apart. They're just bouncing around, so it's very random. The shape of the matter varies with the container. Like a liquid, it takes the shape of the container. Keep that in mind because I'm going to refer back to that in just a minute. The spacing of the particles is much larger. Most of the volume of a gas is actually empty space. And you can see that from the diagram at the top. There's just all kinds of space in between the particles that you don't see in the liquid or the solid. Talking about volume, not only does a gas take the shape of its container, but the volume is actually variable in that it expands to fill the container. So if you took the amount of gas in a little, 1 liter container, and then you put it into a 2 liter container, it's going to expand to take up that entire space. So it's just kind of interesting that the volume is going to change, whereas the volume of the solid and the liquid are not going to change. So that is the end of part 1. Make sure you have all this in your notes and move on to part 2. Thank you.